While the average American family throws away 40% of their food, Amish families waste only 2%. How is this possible? The answer lies beneath the ground, in techniques that have sustained communities for over 3 centuries. Today, we're uncovering 7 genius methods that keep Amish families fed through the harshest winters without a single electrical appliance. Trick 1. Underground refrigeration. 8 feet beneath Amish farmsteads lies a marvel of natural engineering. Root cellars, carved into hillsides and covered with thick layers of earth, maintain a constant temperature between 32 and 40 degrees Fahrenheit year-round. These underground chambers feature multiple compartments, each designed for specific foods. Potatoes rest in bins with precise ventilation, while apples hang in mesh bags that allow air circulation. The earth itself becomes the insulation, creating a natural refrigeration system that never fails, never needs repair, and costs nothing to operate. Trick 2. Preservation method. When autumn arrives, Amish families begin their most intensive preservation ritual. Fresh meat undergoes a 3-stage process that can preserve entire sides of beef for over 12 months. First comes the salt cure, where meat is buried in coarse salt for precise timing based on lunar cycles. Then follows the smoking phase, using specific hardwoods that add both flavor and antimicrobial compounds. Finally, the air-drying stage completes the process in controlled environments. This triple-layer approach creates a barrier against spoilage so effective that families can eat fresh-tasting meat throughout the longest winters. Trick 3. Living pantry. Deep in Amish basements, something remarkable happens throughout winter. While snow covers the ground above, fresh green sprouts emerge from carefully tended containers. This living pantry produces fresh vegetables year-round through systematic sprouting techniques. Seeds saved from the previous harvest become next winter's fresh food source. Mung beans, alfalfa, and wheat berries transform into nutrient-rich sprouts within days. The system operates on rotation, ensuring families always have fresh greens. This banking approach to food storage means that preserved foods from summer continue producing fresh nutrition throughout the coldest months. Trick 4. Along streams and rivers throughout Amish country, water wheels turn 24 hours a day during harvest season. These ingenious mills harness flowing water to power massive food processing operations without consuming any electricity. Grain flows through precisely calibrated grinding stones that operate at optimal speeds for maximum nutrition retention. The constant water pressure ensures consistent results that modern electric mills struggle to match. Community processing days transform these mills into bustling centers of preservation activity. Families bring wagon loads of corn, wheat, and other grains to be processed simultaneously. The water-powered systems can handle tons of food in single sessions, creating efficiency that individual families could never achieve alone. Gravity-fed hoppers ensure continuous operation while community members take turns monitoring the process. These natural power sources integrate seamlessly with seasonal water flows, operating at peak capacity exactly when harvest demands require maximum processing power. Trick 5. Fermentation factories. Beneath Amish, homes lie sophisticated fermentation chambers that operate like underground factories. These temperature-controlled environments maintain precise conditions for cultivating beneficial bacteria that transform vegetables into long-lasting preserved foods. 47 different types of vegetables undergo fermentation using traditional methods passed down through generations. Sauerkraut, pickled beets, fermented carrots, and dozens of other preserved vegetables fill massive crocks arranged throughout these chambers. The fermentation process creates natural probiotics that provide health benefits throughout winter months when fresh vegetables are scarce. Timing these fermentation cycles requires deep knowledge of bacterial cultures and environmental conditions. Traditional recipes specify exact salt ratios, vegetable preparation methods, and fermentation durations that maximize both preservation and nutritional value. These underground factories produce enough fermented foods to supply entire families through winter while creating the beneficial bacteria that support digestive health during months of heavy preserved food consumption. Trick 6. Weather prediction. Amish families possess an almost supernatural ability to predict weather patterns years in advance. This knowledge drives their entire food preservation strategy, determining when to plant, harvest, and preserve based on natural indicators most people never notice. 7-year weather cycles guide long-term planning decisions. Families observe animal behavior patterns, tree growth rates, and atmospheric conditions to predict severe winters before modern meteorologists recognize the signs. Unusual bird migration patterns signal early cold snaps. Thicker animal fur growth indicates harsh weather ahead. Plant behavior provides additional clues about seasonal timing. This predictive knowledge determines emergency food cache locations throughout their properties. Hidden storage areas protect against natural disasters that could destroy primary food supplies. Strategic placement considers flooding patterns, wind damage potential, and accessibility during severe weather. Emergency reserves remain distributed across multiple locations, ensuring survival even when primary storage systems face catastrophic failure. Animal behavior patterns that predict harsh winters help families adjust preservation quantities accordingly. Trick 7. Zero waste. Nothing ever gets wasted in the Amish food system. Every food scrap, every peel, every bone becomes part of a circular system that produces more food than it consumes. Kitchen scraps feed chickens that produce eggs and meat. Chicken waste fertilizes vegetable gardens that feed the family. Vegetable trimmings go to compost piles that enrich soil for next year's crops. Animal integration maximizes food production efficiency throughout the property. Pigs consume vegetable waste and produce meat. Dairy cows turn grass into milk, cheese, and butter. Even bones become valuable resources, boiled into nutritious broths or ground into bone meal fertilizer. Composting systems transform organic waste into rich soil amendments that improve crop yields year after year. These sustainable loops create abundance from what others consider waste. Converting food scraps into valuable resources means families actually produce more food value than they consume, creating true food security through natural abundance. Modern relevance. These ancient methods have never been more relevant than today. Rising food costs and inflation make preservation techniques crucial for family budgets. While grocery prices soar, families using Amish preservation methods can reduce food expenses by up to 70% annually. Modern food supply chains prove increasingly fragile, disrupted by global events, transportation issues, and climate-related challenges. Current food supply chain issues make these techniques invaluable. Recent disruptions have shown how quickly store shelves can empty and prices can spike. Families with year-round food security avoid panic buying and supply shortages that affect millions. Climate change effects on food availability and pricing continue intensifying, making traditional preservation methods essential backup systems. Environmental benefits extend far beyond individual families. Chemical-free preservation methods eliminate exposure to artificial preservatives, colorings, and flavor enhancers found in commercial foods. Energy independence from electricity-dependent storage reduces household carbon footprints while lowering utility bills. Reducing dependence on industrial food systems decreases transportation emissions and packaging waste. Health benefits of traditional preservation methods provide advantages modern processing cannot match. Fermented foods create beneficial probiotics that support digestive health and immune function. Natural preservation maintains higher nutritional content compared to commercial processing that destroys vitamins and minerals. Community resilience and self-sufficiency benefits strengthen local food security and reduce vulnerability to supply chain disruptions. Nutritional advantages of traditional preservation often exceed fresh foods. Properly fermented vegetables contain higher vitamin levels than their fresh counterparts. Traditional drying methods concentrate nutrients while commercial dehydration destroys them. Salt-cured meats maintain protein quality better than chemical preservatives. These methods create foods that are not just preserved, but actually improved through the preservation process. The knowledge represents generations of tested wisdom. Unlike modern preservation that relies on artificial chemicals and energy-intensive processes, these methods use natural processes that have sustained communities for centuries. They provide genuine food security that doesn't depend on external systems, supply chains, or technology that can fail when needed most. Family adaptation. Modern families can successfully implement these techniques with practical modifications for contemporary living spaces. Urban and suburban homes offer more opportunities than most people realize. Basements provide ideal environments for fermentation chambers and sprouting systems. Garages can accommodate root cellar modifications with proper insulation and ventilation systems. Apartment-friendly versions make these techniques accessible even in small spaces. Balcony fermentation setups work efficiently in containers designed for urban environments. Small-scale sprouting systems operate successfully on kitchen counters or near windows. Container gardening produces surprising amounts of food for preservation in limited spaces. Starting small allows families to develop skills gradually without overwhelming initial investments. Beginning with simple fermentation projects builds confidence and knowledge. Single vegetable preservation projects teach fundamental techniques before expanding to complex systems. Success with basic methods provides foundation for implementing larger-scale operations. Community approaches multiply individual efforts exponentially. Neighborhood sharing of processing equipment reduces costs while building local food security networks. Cooperative preservation days allow families to process large quantities together. Knowledge exchange between families accelerates learning and prevents common mistakes. Modern tools enhance traditional methods without compromising their effectiveness. Digital thermometers provide precise temperature monitoring for fermentation chambers. Improved ventilation systems ensure optimal conditions for root cellars. Modern materials create more durable storage containers while maintaining traditional preservation principles. Safety considerations require attention in home preservation systems. Proper pH testing ensures safe fermentation processes. Temperature monitoring prevents spoilage in storage systems. Understanding botulism prevention keeps families safe during preservation activities. Legal aspects vary by location regarding food preservation and sharing. Local regulations may restrict certain preservation activities. Zoning laws might limit storage construction projects. Understanding community rules prevents conflicts while building food security systems. Building community networks creates support systems for learning traditional preservation skills. Finding experienced practitioners provides mentorship opportunities. Joining preservation groups offers access to equipment and knowledge. Creating local networks strengthens entire communities against food insecurity, while preserving valuable traditional knowledge for future generations. Complete system. These 7 techniques function as an integrated system where each method supports and strengthens the others. Root cellars store fermented foods at optimal temperatures. Water-powered processing prepares vegetables for fermentation chambers. Weather prediction, timing, coordinates all preservation activities for maximum effectiveness. Zero-waste systems ensure nothing valuable gets lost while feeding the entire operation. Redundancy throughout the system ensures families never face hunger even when individual methods encounter problems. Multiple preservation techniques applied to single food items create backup system. Distributed storage locations protect against localized disasters. Diverse food sources prevent dependence on any single preservation method or food type. Seasonal coordination synchronizes all methods for optimal results. Spring planting determines preservation quantities based on weather predictions. Summer cultivation focuses on varieties that preserve well using available methods. Autumn harvest timing maximizes preservation potential while coordinating community processing activities. Winter monitoring ensures stored foods maintain quality throughout the cold season. Long-term planning spans multiple years, creating abundance that grows over time. Seed saving ensures independence from commercial suppliers. Soil improvement through composting increases crop yields annually. Knowledge accumulation builds family expertise in all preservation techniques. Infrastructure improvements expand capacity and efficiency each year. Backup systems activate when primary methods face challenges. Alternative storage locations protect against single-point failures. Multiple preservation methods for critical foods ensure availability. Community support provides assistance during difficult seasons. Emergency reserves maintained separately from daily food supplies. Cross-seasonal food availability strategies ensure dietary variety throughout the year. Different preservation methods provide different nutrients during various seasons. Rotation systems ensure families consume foods at peak quality. Seasonal variety prevents dietary monotony while maintaining nutritional balance. Community cooperation enables large-scale preservation impossible for individual families. Shared equipment reduces costs while increasing capabilities. Coordinated processing maximizes efficiency and reduces waste. Knowledge sharing prevents lost techniques while improving methods. Group purchasing power reduces supply costs while ensuring quality materials. Emergency preparedness through food security strengthens entire communities against uncertain times. Practical steps. Begin immediately with simple fermentation projects requiring minimal equipment and space. Sauerkraut needs only cabbage, salt, and a jar. Fermented vegetables can start this week using vegetables already in your kitchen. These beginner-friendly projects have high success rates and build confidence quickly. Simple tools and materials for starting include wide-mouth jars, sea salt, and fresh vegetables. Most families already own everything needed for basic fermentation. Additional equipment can be acquired gradually as skills develop. Investment remains minimal while learning fundamental techniques. First steps for each method should focus on single techniques before combining approaches. Start root vegetable storage in cool basement areas. Begin sprouting with mung beans or alfalfa seeds. Try basic fermentation with cabbage or cucumbers. Each success builds foundation for more complex preservation projects. Building your year-round food security plan requires systematic approach over multiple seasons. Document what works in your specific environment. Track seasonal timing that produces best results. Record quantities needed to supply your family through winter months. Budget considerations vary significantly between methods, but most start inexpensively. Fermentation requires minimal initial investment. Sprouting systems cost almost nothing to begin. Root cellars require more investment but provide decades of service. Water-powered processing needs community cooperation, but individual investment remains reasonable. Timeline for implementing all 7 methods spans several years for most families. First year focuses on learning basic fermentation and sprouting. Second year adds storage improvements and expands fermentation varieties. Third year incorporates weather prediction and waste reduction systems. Fourth year achieves integration of all methods. Common mistakes include rushing processes, inadequate temperature control, and insufficient salt in fermentation. Avoiding these mistakes requires patience and attention to traditional timing. Success comes through following proven methods rather than experimenting with shortcuts. Measuring success involves tracking food waste reduction, storage duration, and family nutrition improvement. Successful preservation maintains food quality throughout storage periods. Effective systems reduce grocery expenses while improving dietary variety. Ultimate success means achieving genuine food security independence from fragile supply systems while strengthening family and community resilience. These 7 genius tricks work together to create complete food security that has sustained Amish families for generations. Underground refrigeration, triple-layer preservation, living pantries, water-powered processing, fermentation factories, weather prediction strategies, and zero-waste ecosystems form an integrated system more reliable than any modern alternative. While the world faces increasing food insecurity, rising costs, and supply chain disruptions, these time-tested methods offer genuine solutions. The Amish way proves that true abundance comes not from consuming more, but from wasting nothing and working with nature's own preservation systems.